Okay, let's do some examples. Well, let's start with the base case. We know that in this case, the base case is the dash LOE function called with empty for the LOE. That's where the mutual reference and self-reference cycles all stop. So we'll say check, expect, find dash LOE. Let's say we're looking for F3 in empty, and of course we can't find F3 in empty because there's not anything in empty at all, so that'll produce false. Now let's do another simple case. Let's say check, expect. Let's look for its find dash dash LOE and find dash dash element. Let's say we're looking for something named F3 in F1. Well, that's false. There's nothing named F3 in F1. And most of these other tests are going to be find in element. So we'll make that something we can copy. Well, what if we look for F3 in F3? Well, if we look for F3 in F3, we do find it. We find it right away because F3 is F3. And so we return the data, which is 3. Okay, so that's the base case and two very simple immediate success or immediate failure cases. Let's try to do another case. Let's look for F3 in D4. Well, that's false. We don't find F3 in D4. But what about looking for F1 in D4? Well, we do find that. F1 is the first child of D4, so this is going to produce 1. But what about a case where what we're looking for is not the first child of D4, but one of the later childs of D4? We should try that case because it kind of corresponds to searching in a list and making sure we search beyond the first element. So if I look for F2 in D4, I'm going to find it, so the data will be 2. Seems like we should also try a case where we're looking in an element that has subs, but what we're looking for is actually the element itself. So let's see what happens when we look for D4 in D4. Well, anything that has subs has data 0. So this is going to produce 0. And let's try one more big one. Find dash dash element. Let's try looking for F3 in D6. That's the far right child, and that would produce 3. So that seems like a pretty exhaustive set of tests. Let's run those tests to make sure they're well formed. They're all running and most are failing, so they are well formed. And let's save that. Okay, now let's go get the template. 2 of them, of course. Here they are. We'll go back down to the function that we're working on. We'll comment out the 2 stubs. Paste in the templates. Uncomment those. Now do the renaming. Find element is that, and here's the natural mutual recursion. Copy that. Here's the function name, here's the natural recursion, and here's the natural mutual recursion. And there's one more thing to do here. These are functions that consume 2 arguments. They consume the element or the list of element, and also the name of the element we're looking for. So we have to add a parameter n there, and we have to add a parameter n there. And remember, I said whenever you have recursion, and it also applies for mutual recursion, when you add a parameter, you should be sure to go put a note to yourself at each recursive or mutually recursive call to say, hey, you're going to need something here. You're going to need a parameter. Now we could wait till later to fill in those question marks. But in this case, I know that once I start looking for a given n, the whole way down the tree, I'm going to be looking for the same n. So n's never going to change. N is always the same value. So I'm just going to keep passing n in all the recursive calls. I can fill it in now. Now, if that's not clear to you now, or if you don't think it would have been clear to you this early, That's fine. You can leave the question marks and fill them in later. I can just tell now that this function doesn't change the n as it goes, so I might as well fill it in now.